Welcome to AskPrep, your trusted companion for UPSC and IAS preparation. Today we will study about a very important topic of technology, which is quantum computing, the next frontier. Before we begin, let's understand the basics. Classical computers, which we use every day, process information in bits, represented as either 0 or 1. However, quantum computing operates on quantum bits or qubits. Unlike classical bits, qubits can exist in a state of 0, 1, or both simultaneously, thanks to a phenomenon called superposition. This unique property allows quantum computers to perform complex calculations at unimaginable speeds compared to classical systems. Another crucial concept in quantum computing is entanglement. When qubits become entangled, the state of one qubit is directly related to the state of another, no matter how far apart they are. This interconnectedness enables quantum computers to solve problems that are currently beyond the reach of classical computers. Well, quantum computing is increasingly becoming a part of India's technological roadmap and global scientific advancements. Understanding its basics can give you an edge in topics related to science and technology, governance, and even ethics. India has recognized the potential of quantum computing and is making significant strides in this field. The National Mission on Quantum Technologies and Applications, launched by the government, is a step towards harnessing the power of quantum technologies. With a budget allocation of over 8,000 crore rupees, this mission aims to position India as a leader in quantum research and innovation. Another fundamental principle of quantum computing is entanglement. When qubits become entangled, the state of one qubit becomes dependent on the state of another, no matter how far apart they are. This property enables quantum computers to perform parallel processing on a massive scale, providing unprecedented computational power. The potential applications of quantum computing are vast. In the field of cryptography, quantum computers could break traditional encryption methods by rapidly solving complex mathematical problems that are currently infeasible for classical computers. Conversely, they can also create virtually unbreakable encryption systems through quantum key distribution. In pharmaceuticals, quantum computers can model molecular interactions at an atomic level, accelerating drug discovery and reducing the time and cost involved in bringing new medicines to market. In logistics and supply chain management, quantum algorithms can optimize routes and resource distribution with incredible precision, leading to more efficient systems. Climate modeling, which requires processing vast amounts of data, could become significantly more accurate with quantum computing, enhancing our ability to predict weather patterns and understand climate change. Let's explore the potential applications of quantum computing. First, in cryptography, quantum computers can revolutionize data security. Classical encryption methods rely on complex algorithms, but with quantum computing, we can create virtually unbreakable encryption using quantum key distribution. Next is drug discovery. Pharmaceutical companies can use quantum computers to simulate molecular interactions, drastically reducing the time and cost of developing new drugs. This has implications not just for healthcare but also for addressing global challenges like pandemics. In the field of logistics, companies can optimize supply chains with quantum algorithms, ensuring faster delivery and cost savings. Similarly, quantum computing can transform artificial intelligence by solving problems like pattern recognition and machine learning more efficiently. However, quantum computing isn't without challenges. One of the biggest hurdles is error correction. Quantum systems are extremely sensitive to their environment, and even minor disturbances can cause errors. Researchers are actively working on building more stable systems to overcome these issues. Another challenge is the high cost of development. Quantum computers require specialized environments and resources, making them expensive to build and maintain. Despite these challenges, countries like the US, China, and India are heavily investing in quantum research, seeing its potential to revolutionize industries. However, quantum computing isn't without challenges. One of the biggest hurdles is error correction. Quantum systems are extremely sensitive to their environment, and even minor disturbances can cause errors. Researchers are actively working on building more stable systems to overcome these issues. Another challenge is the high cost of development. Quantum computers require specialized environments and resources, making them expensive to build and maintain. Despite these challenges, countries like the US, China, and India are heavily investing in quantum research, seeing its potential to revolutionize industries. As IS aspirants, it's crucial to understand how quantum computing aligns with policymaking and governance. For instance, its applications in cybersecurity can enhance national security by protecting critical infrastructure from cyber attacks. Quantum technologies can also contribute to smart governance by optimizing complex systems like urban planning and resource allocation. Furthermore, the ethical implications of quantum computing deserve attention. Questions arise about data privacy, equitable access to technology, and the potential misuse of such powerful tools. These are areas where policymakers will need to strike a balance between innovation and regulation. The future of quantum computing is promising. With advancements in hardware, algorithms, and global collaborations, we are on the brink of a technological revolution. For India, this represents an opportunity to not only strengthen its scientific community but also to emerge as a global leader in technology. To conclude, quantum computing is more than just a technological advancement, it's a paradigm shift. As UPSC aspirants, understanding its fundamentals, applications, and implications can help you approach science and technology topics with confidence and depth. Stay curious, stay informed, and keep preparing with AskPrep. Thank you. This is AskPrep, your guide to mastering UPSC and IS preparation. Let's decode complex topics and simplify your journey to success.